Welcome back to another episode of Game Development Beyond the Basics. I'm Eric Freeman, and today we're going to be taking a look at how to play an animation clip without needing an Animator Controller in an animation state. This concept has a lot of applications in game dev. You can free up space in your animator because you don't need a state for every single permutation of action a character can take. Think of a game like Dark Souls or Elden Ring, where you can collect different gestures throughout the world. There could be tons of these, and creating a state for every single different gesture can become pretty unwieldy. A system like this will allow you to keep your animator states clean and just override it with a simple script call. You can also use it for some kind of smart objects in a scene where the objects themselves provide the animation clip they use to be interacted with. Think of a game like The Sims, where everything from the refrigerator to the shower has its own unique one-off interaction animation. Instead of needing a bloated animator controller with states for thousands of different interaction animations, you can have the objects themselves provide the animation clip they'll use to be interacted with. Before we get started, I want to say that there's another way to accomplish the same type of outcome using the animator override controllers, but that system is well documented and easy enough for beginners to figure out. Unfortunately, there's zero videos on the Playables API here on YouTube, poor documentation online, and every forum question is answered by the same guy plugging their third-party solution you can buy on the asset store. So, in an effort to help demystify this old and half-finished API that the entire animator and timeline is built on top of, let's take a look at the Playables API. I'll be using this abandoned project I already have as the base for this tutorial. There's nothing special here, just a basic third-person character controller I whipped up that's about 200 lines of code. Playables are small nodes that can be created at runtime by script that you can chain together for interesting effects. Built-in nodes like the Animation Clip Playable, Animation Mixer Playable, and Animator Controller Playable are how we're going to achieve the effect linking an animator controller running in the animator component, the built-in mechanim state machine you're already familiar with, and mixing it with an animation clip being processed by the Animation Clip Playable. The Playables API isn't limited to just animation, as the whole timeline system uses it. This is how you can trigger sound playback, tie into scripts and animation jobs, and even write your own custom tracks, behaviors, and mixers. I use this system a lot for how we do cutscenes in Samurai Unicorn, where I had to write custom tracks for everything from fading UI, subtractive fading the screen, to subtitles. There's actually a half-finished package Unity made to help visualize the Playable Graph. In classic Unity fashion, it stopped showing up in the package manager several years ago, even if you have Enable Pre-Release Packages turned on in the settings. Someone asked about this 2 years ago on the forums, and a Unity employee said they're looking into it. They haven't given an update on it since, so I can only imagine they're lost somewhere in the sea of office closures and layoffs, still desperately trying to find us an answer. Godspeed, H. Bonin. Thankfully, we can install by git URL, so let's grab the URL and toss it in. Once it's installed, go to Window, Analysis, Playable Graph Visualizer. Now for my animator controller, it looks like a mess with hundreds of clips. Unfortunately, Unity never got around to implementing zooming or panning to this graph. However, it does help give us an overview on the animation controller I set up for the player. You can see the animation output node is connected to an Animator Controller Playable. This Animator Controller has an animation layer mixer, which is hooked up to an animation mixer for each layer the controller has. The animation mixer at the top is my character's locomotion blend tree. You can see different nodes light up as I do actions that run on different layers, like my additive firing layer or upper body override for throwing grenades. At the end of the day, what we're going to do is add in a mixer between the animation output node and the animator controller node, and then we'll have that new mixer blend between the animator controller and a new animation clip node that we're going to programmatically add. This way, we can easily blend between the animator controller and a one-off animation clip. So this is a nice overview and all, but now it's time to get our hands dirty. I'm going to create a new script called one-off animation, where we'll be doing all the logic for this tutorial. I'm going to start by clearing everything off, adding a reference to an animator, and creating an onValidate method to automatically populate it if it's null. Let's add a reference to an animation clip in a private playable graph. In the start method, we can create the playable graph and name it something that will be easy to find in the playable graph visualizer in case you have lots of playables in your scene. Let's create an animation playable output, which takes in the graph, a name, and the animator the output will be targeting. This means that the animation playable graph will output the animation data of the graph to the existing animator on our character. Now let's create an Animator Controller Playable, which takes in the graph and the animator's runtime animator controller. This runtime animator controller is how we're able to grab the internal state of the animator controller and provide it to the playable graph. We can set the graph's animation playable output source playable to the animator controller playable and call graph.play. Now, our basic system is glued together. We're creating a playable graph that overrides the animator component on our character and then provides it the existing output from the animator's animation controller and using the animator controller playable. Effectively, we're doing nothing here. If we go back to Unity now and add our new script to the character, you'll see there's no change to how the game works. If I switch the playable graph to visualize our new graph, you'll see it looks exactly the same as a visualizer for just the animator. But now is where the fun begins. Let's go back to our script, and instead of setting the animation playable output source to the animator controller playable, we'll create a new animation mixer playable here, defaulted to just have one output. Let's set the animation playable output to the mixer, then connect the mixer's input 0 to the animator controller playable's output 0. This is just plugging the animator controller into our mixer, and our mixer is now plugged into the animation output. I'm going to set the mixer's input weight for the animator controller to 100%, so it passes on all of the animator controller's output. Now we can go back to Unity and see that once again, the game controls exactly the same. But now when looking in the Playable Graph visualizer, we see our new animation mixer node nestled right between the animation output and the animator controller. We're actually super close now to having a basic version of this working. Let's jump back to the code, change the animator mixer playable to have 2 inputs by default, and add a new animation clip playable where we pass in the graph and the clip parameter we made earlier. Now we can just connect our animation mixer's second input slot to the animation clip playable's first output. Back in Unity, we can run the game and see that the animation mixer is now blending between the animator controller and the animation clip. We set the animator controller's weight to 100% earlier, which is why the connection between it and the mixer is fully visible and the one between the mixer and the clip is faded. Our next step is to assign an animation clip to the clip field so it has something to play back. I'm going to use something I grabbed off Mixamo. Make sure it's humanoid and set to looping. Let's assign the animation to the clip field. Just to show it working now, if I set the animation mixer's input weight of the second slot to 100% and then jump back to Unity, you can see it looping the joyful jump on the Stormtrooper like we'd expect. While this clearly improves gameplay tremendously, let's switch it up so we can blend between the 2 clips with a slider. We start by pulling the mixer variable out into a private variable, creating a weight variable which I'll decorate with a range attribute to get a nice editor visual, and then in update, I'll set the animation mixer's input weight for the first input to 1 minus weight, and the second to just weight. This way, if the animation clip's weight is 75%, we'll still get 25% of the animator controller coming through. This also will allow us to seamlessly crossfade between the controller and the clip in a future step, so it's not an abrupt interruption when we start playing the animation clip. Hopping back to the editor, we can play the game and see that by default, our character's animation is being driven by the animator controller, and then when I drag weight to 1, it transitions to our joyful jump. We're getting close now, but we're still not done having fun yet. This current system has an issue that we can't play an arbitrary clip whenever we want, and when we adjust the weight to 1, who knows what time during the playback the clip will start at. We can get a basic version of this working pretty quick though. I'm going to pull the Clip Playable variable out into a private variable, and then in the update, let's just check if the player presses a key, and if so, call a new function called play. Play will take in an animation clip for the animation we want to play. Now let's grab our clip creation and hooking it up to the mixer code out of the start function and put that into play. I'm going to set the animation clip's duration to clip.length. I don't think this is necessary here since we're remaking the animation clip playable, but if we were just reassigning the Playables clip field instead, we would need to do this. Now let's set the animation clip Playables time to 0. Also, not necessary, but good to know about if you encounter bugs in the future related to these two. Let's hop back to the editor just to check what we've added so far. I'm going to turn off the joyful jumps looping just to help visualize this. If we run the game, we can see the animation mixer only has one input hooked up to it. If we press 1 on the keyboard, it will create a new animation clip playable and hook it up to the mixer. If we drag the weight to 1, the animation is stuck on the last frame since it's no longer a looping animation, and if we press 1 again, it plays back the animation from the beginning. This works, but it looks like I forgot to call the mixer's disconnect input method first, so it's throwing some errors in the console. Let's clean that up. Now it'd be great if we didn't have to keep fiddling with that weight slider and instead let the mixer's weight be driven by if there's a clip playing or not. We'll do this by switching the animation mixer to have only one input by default, then in our play method calling the mixer's setInputCount method and passing 2. In update, let's wrap our input weight lines in an if statement saying if mixer's input count is 2, do that, otherwise set input 0 to 100%. Finally, we can check if animation clip playable is done under the weights, and if so, disconnect that input, set input count back to 1, and destroy the clip playable. Back in the editor, we can see the animation mixer has only one input by default. Playing the clip creates a new animation clip node and hooks it up to the mixer, and once the clip is done playing back, it cleans itself up and the mixer's back to the default of only one input. Besides the issue of snapping the weight to 100% as soon as the animation clip starts playing back, it's looking pretty good. Getting the weights to adjust for us is pretty easy as well. Let's grab the clip's current time, normalize it by dividing the time by the clip's duration, then create a new local weight variable defaulted to 1D. If time is less than 0.1, set weight to normalized time divided by 0.1. Else, if time is greater than 0.9, set weight to 1 minus normalized time divided by 0.1. Now, just change the set input weight calls to reference our local weight variable casted as a float. We can also clean up that old weight slider since we're no longer using it anymore. Back in the editor, we can run around, and when we press 1, it smoothly transitions over the first 10% of the animation to our joyful jump, and then smoothly transitions back to our regular Animator controller for the last 10% of the animation. Just to make sure the math is clear for everyone, let's create some variables so you get a better look at how the fade in and out calculations are made. While this is great and all, it's still not a real-world scenario yet. Let's remove the keydown check from our one-off animation script, and instead, I'm going to add a reference to the script to my third-person character controller. Toss a couple animation clips on, and then somewhere in here, I'll check if you press 1, play the first test clip, and if you press 2, play the second test clip. Now this is probably a good time to mention that I forgot to update my Animation Clip Playable.create method when making my play method earlier because it's still using the public animation clip and not the one passed into the play method. Let's fix that bug real quick and remove the now unused public clip variable. I can assign the reference to our one-off animation script and a couple test animations in the editor, and running the game, I can see that pressing 1 will play Joyful Jump like before, and pressing 2 will play this shuffling animation. Our little stormtrooper sure does have the moves now. So one thing I haven't brought up yet is you have to actually manually dispose of this stuff, or else you can run into memory leak issues. I know we're all used to C#'s garbage collector, or Unity handling the lifecycle of game objects for us, but with these playables, we need to make sure to manually clean them up ourselves. You might have noticed by now that the graph we created is still viewable in the visualizer even when the game isn't running. We can clean that up in an onDestroy method. You might be surprised that we need to check if the graph is valid instead of checking if it's null, but this is because playables are structs, which means they're value types and they cannot be null. Think of basic value types like ints or floats. They're never null if they're not set, just defaulted to 0. That's why there's this handy isValid method, so we can check that to see if they need to be disposed. Now when we go back to Unity, run the game, and then stop it again, our player graph no longer shows up in the Playable Graph Visualizer dropdown. You might have also noticed by now that every time I throw a grenade, 2 grenades come out. That's because the throw grenade animation has an animation event on it for when the grenade should be spawned. And we're missing a step when setting up our graph. Even though we're targeting the animator with our Playable Graphs output, and passing the runtime animation controller onto the Animator Controller Playable, the animator is still also running the Animator controller. We can verify this is happening because both graphs are visible in the visualizer's dropdown. We can clean up this issue easily by nulling out the animator's runtime animation controller after we pass it on to the Animator Controller Playable. Back in Unity, we can now see that only the graph we set up from code is visible in the dropdown. However, now this brings in a new issue where all of our animator.play and animator.crossfade calls in our character controller no longer work. In fact, we can see an error in the console saying Animator does not have an animator controller. Fortunately, this is an easy fix. We just need to bring the Animator Controller Playable out into a public variable and then update the method calls in our character controller to reference the Animator Controller Playable instead of the animator. Now our Stormtrooper is back in business. Before I forget, let's make sure to destroy the Animation Clip Playable in our play method, just in case we trigger a clip while one's currently playing, since it'll never get disposed of properly in that case. And now it's time to address the elephant in the room, animation curves. Any curves on an animation clip playing through the Animation Clip Playable do not update the animator's properties like they would if they are running inside of an animation state. I use animation curves for lots of things in this project, like limit movement curve to slow down movement during parts of an animation, or disable left hand IK so the left hand can release the blaster to throw a grenade. This is a problem because the limit rotation curve to stop the player from facing the movement direction isn't being read in during the joyful jump, which is why you've probably noticed the Stormtrooper spinning around sometimes while that animation is playing. While the fix for this isn't quite as easy as the one for animation events, I'm sure you're just as excited as I was to figure this mystery out. The first step is we need to use a new type of playable, an animation script playable. We just need to slide one right in between our animation playable output and the animation mixer. And then in the script, read out the properties and send them back to the C# side. This part of the code might be a little confusing if you haven't played around with Unity's job system before. Jobs are just performant ways to take advantage of multi-threaded computers and run little scripts on other threads instead of blocking the main gameplay thread. We start by creating a struct called readCurveJob that implements iAnimationJob. This job needs a native array of type propertyStreamHandle called curves, and a native array of floats called values. If you've never used a native array before, it's a way to share a reference between code executing on the main thread and code running in the job system. Inside process animation, let's loop through the curves and update the values array with the curve's float value from the animation stream. And we're 100% done with the jobs code now, so if this was your first steps with the system, I hope it wasn't too bad. Now let's scroll back to the top and create a new animation script playable. In the start method, we're just going to call create, passing in the graph, a new read curve job, and set it to have one input. Now connect the mixer and change the animation playable output source to the script playable. Next up, let's create a list of strings called exposed curves, which is where we'll be able to define which animation curves we want the job to grab for us. Then, let's create the native arrays for curves and values. Let's pass them into the read curve job while we're making it. Now we can just create values by creating a new native array of floats, passing in the exposed curve's length and allocator.persistent. Same thing for when creating curves. Now let's loop through exposed curves and create the property stream handle for each of them by calling animator.bindStreamProperty, passing in the animator's avatar root, type of animator, and the string name of which property we're binding to, which in this case is just the value of the exposed curve array. Just to visualize these values quickly, in the update method, we can loop through exposed curves and log out the values with my debug text logger. This is a simple script I made, which handles logging out to a TextMesh Pro text for me. I have it sitting on a TMP text I already have set up in the UI. Anyways, back on the player object, let's add a couple parameters to the exposed curves. Let's start with limit movement and limit rotation. Ignore the memory leaks in the console for now, because the main thing I want to show is that while the curves still aren't updating in the animator's parameters when being run from the playable, they are being logged out on the screen to the values we'd expect. We're in the home stretch now. Let's change the limit rotation code from reading the value from the animator to grabbing it from our values array. Back in Unity, we can see now that the joyful jump correctly stops letting the player rotate during the animation playback. The final thing we need to do is clean up the last of the memory leaks. C# is managed code, which means it's code managed by the Common Language Runtime, and that has nice features like the garbage collector that cleans up memory automatically for us. These native arrays are actually pointers to the unmanaged C++ side of the engine, which is why we have to manually clean them up ourselves. I'm going to copy-paste the clip cleanup code from Play over to onDestroy just to make sure there's no issues if we stop the game midway through an Animation Clip Playable playing a clip. Then, let's call dispose on both curves and values. And there we have it, a nice little way to play a one-off animation clip while still making use of both animation events and animation curves. I know I poked fun at Kybernetic earlier in this video, but I really want to thank him for answering so many questions on the Playables API over on the Unity forums. Almost every time I was searching for answers to some obscure question I had with the system, he popped up in the thread with an answer. I also learned a lot by reading through the source code for his Animator plugin, which I've actually owned for years now, despite never using in a project, and that's because I have an asset store addiction that I should probably see someone about. I also want to give an extra big thank you to Solarian Z over on the Unity forums for answering so many questions I had while writing this script. This video would not have been possible without him. He also wrote a Playable Graph visualizer that supports panning and zooming and gives a nice little mini-map of your graph. It's free on GitHub, but there's also a paid version on the asset store in case you want to help support him. On a personal note, I always joke around that I started this channel to make videos on topics that either don't have a lot of information out there on them or are interesting for about 3 other people on the planet. I've been absolutely overwhelmed with the amount of support that my channel has received so far. 300 subscribers is about 297 more than I expected this channel to get, so whether it's your first time here or you're already subscribed, thanks so much for watching. And once again, I'm Eric Freeman, and this has been Game Development Beyond the Basics. If we run the game, we can see the animation mixer only has one input hooked up to it. If we press 1 on the keyboard, it will create the new animation clip playable and hook it into the mixer.